What's up everybody, welcome to Moto. Today we're going to try to do some tail light debugging to make sure that we have the right numbers for the fix that I need, and I'll show you guys what that is later on. Okay, so this is the new tail light that I installed. It's a bit longer. Still looks pretty clean. And in terms of how it works, we get some power going. It's nice and bright, quite visible. When the rear brake is actuated, it actually blinks. However, because the LEDs on it are actually, even though there's more of them, they I think are smaller, and the way it's wired is slightly different, so the amount of current it draws and amount of power usage is less than the old one. So when the bike is started, the brake light actually doesn't work. So when we press it, it actually doesn't blink. And to show you, we can start the bike. Just flip this a few times. Give it full choke. So as you can see, it's red and nothing. So in order to resolve this, I've got my multimeter, and we're going to try to measure the I actually have the old light bulb, so I'm going to plug that in and measure the current that draws, as well as the once I measure the current, then I'll know the resistance of that. Then I'll measure the current that this one draws, as well as the amount that the LEDs on the back end up drawing, because those are technically on the same circuit. And we're going to compute how much resistance I need to add to the whole circuit in order to equalize or trick the system into thinking that there's more power being drawn, and hopefully resolve that issue. So let's plug in the old light bulb and measure things out. Okay, so I have the old light bulb. This is a a 5-watt Stanley 1157 bulb. The original setup, the bike has 2 of them, so one running on each of these brown line circuits. So I'm pretty sure that these circuits in this box are being split up, and essentially they're running in parallel. So right now what I'm doing is I'm hooking up my new tail light to one of these circuits, and the rear license plate LED lights to the other circuit. So by learning how much this one is drawing, we should be able to determine, essentially with doing some simple physics, calculate how much the draw of both of them when both of the parallel lines would be, and then we're going to measure that one and this new one, to figure out what we're actually getting for the new ones, and compute what we need to change. So in order to measure this out, so I have the multimeter set up here. What we're doing is we're connecting the positive to the multimeter, and then the black or negative to the positive end of the light bulb. So essentially the multimeter is in line with the light bulb. So if we were to set that up, we have the positive, we turn the power on, light comes on, and we have a reading of 0.53 amps, or 530 milliamps. Okay, so that's the old bulb. So now let's measure the new brake light and see how much the difference there is. Okay, and now we have the new light. Okay, power is on, and we're getting 0.28 amps, or 280 milliamps. Okay, so that's about half of that. We'll record that in, and we just need to measure out the LEDs on the back. So, okay, and now for the rear LEDs, I have them on, and they have a substantially less 0.065 amps or 65 milliamps. So we have our numbers to calculate essentially how much resistance we need to add onto these circuits to simulate the 530 milliamp draw of the 5 watt light bulb. Okay, so I'm going to pack this back up. Okay, so we're going to, now that we're back inside, I'm going to show you how to calculate the proper resistors that you need to add to your circuitry in order to make up for the lack of draw from the LEDs. So in order to do that, first we're going to simulate the existing circuit. So for that we're going to need a battery that's going to provide 12.8 volts, and then we're going to need, we did measure the Stanley 5 watt light bulb to be at 530 milliamps. So by using Ohm's law, we can figure out what the resistance of that light bulb is. So to do that, we're going to just pull up Ohm's law calculator. And we know we're going to be running 12.8 volts. And we know that we had 530 milliamps. So we have a resistance of 24.15094 ohms. So in order to simulate that light bulb, we're going to add a resistor. And we're going to make that resistor be that exact same ohms. So in order to simulate our circuit, we're going to add some wires. Let's do 90 degree like that. Boom. So we have our circuit running. Just to make things a little bit more obvious, we're going to show the current here, before and after. Okay, so essentially we have that 530 milliamps and 24 ohms of resistance, and that is eating up the full, you can see that that's using almost 7 watts in here, which is fine. That's how that light bulb works. So now we're going to simulate our tail light and our LEDs. Because both of them on my bike are currently hooked up to the same circuits that used to have this type of setup on them, we're going to essentially simulate those as well. So in order to do that, we're going to stop our simulation here. We're going to add another battery. Make that 12.8. And we know that for the tail light we had 280 milliamps. So if we clear this out, 280 milliamps, we have 45.71429 ohms of resistance. So we will create a resistor for that. Okay. And we add our wires. And now if we were to run our simulation, we can see how different this is actually from the normal light bulb. So you can see in here we already have, maybe I should have made this the same size. we have 280 milliamps, and the problem that we see here is that well, that's clearly not the same amount. So we need to add something to the circuit to make the amount of power drawn from the battery be about the same amount. So in order to do that, we're going to use simple physics and essentially add another resistor in parallel with this one. So in order to do that, we're going to move our resistor down onto a separate circuit. And then we're going to add another resistor to the circuit in parallel with this one. Now, this new resistor that we're adding in, we have to make it be essentially the same amount, the added enough resistance so that our current running through the whole circuit ends up equaling the same amount as in the normal light bulb case. So in this case, if we do the math, and this is again simple Ohm's law physics, I believe we end up with something like 51.7 ohms, 51.5, or 51.2. Yeah, so 51.2 ohms will result in the same 530 milliamp current being drawn. And that should essentially even out the, or be as close as possible to evening out the power draw on the tail light circuit. Similarly, we're going to do the almost an identical thing for our license plate light bulbs. So for those, again, we're going to add a battery. That's 12.8 volts. And again, we're going to add some wires. Since we know that we're going to need another resistor on top. The resistance of the tail light, the license plate lights was 0.65 milliamps. So again, using our calculator here, if we do 65 milliamps, we have 196 ohms resistance. Okay, so we can run that and we can already see that the current there is significantly less, right? So we need to add that extra resistor in order to bump up that amperage usage. In this case, if you did the math, I believe it was 27.5. Yep. And that will result in the same amount. So really what we're what we need to add to both of these circuits is technically a single resistor. If we are able to find a resistor that's exactly this amount of resistance, that'd be great. But if it's not, then a resistor with the closest to this resistance would probably be preferential. One important thing to mention here is if we, using this tool, if we hover over, or you can do the math yourself, you can see that the resistor in the tail light case uses 3.2 watts of power. So the resistance that we need to add, if we can find an exact one, would be a 3.2 watt resistor with 51.2 ohms of resistance. That's highly unlikely that we're going to find something like that, so probably the next best thing would be a 5 watt resistor with 51 ohms. So if we were to change this to actually be 51 ohms exactly, we'll see that that will actually end up resulting in drawing a little bit more than the usual set, which is fine. Similarly for the tail light, the license plate lights, you can see that here the wattage is actually a lot higher, so almost 6 watts of power and a 27.5 ohm resistance. So it's unlikely that we're going to find something that's between 5 and 10 watts. So it's probably best to jump up to a 10 watt resistor with a 27 ohm resistance. So that would again bump up the consumption on this a little bit higher, which is fine. And that should actually make things even out the power that we need on both of those circuits, so that the electronics and the rest of the bike will think that the regular 5 watt light bulbs are still in place, and we can go on things normally. You can use this method to figure out your own setup. The only measurements you'll need is what the original amperage was on the existing light bulbs and how many light bulbs there are, so that you can figure out what the resistance of those is, and then from there you can build the rest of the circuits that you need. Alright, so now that we know what we need, all that remains is to just go purchase the new resistors and wire them in, which we'll do in the next episode. So thanks for watching, make sure to subscribe, hit the little bell for notifications, and I'll see you next time.